Alright, welcome back. I need to evaluate this thing. What? So... We're gonna do the really intelligent thing called I'm going to replace pi by a random real number and then set that real number equal to things for which I can actually compute this and then see if I notice anything, because I don't have any other ideas. Alright, so if I raise if pi equals 1, and please don't quote me on that, unfortunately, I don't know what the integral of square root x is either. Shit. 2/3 x to the 3/2, right? Okay. And then 2/3 x plus 1 to the 3/2. Okay, and also, like, this is as good as it's got. Like, I'm not missing on a different way to write this, I hope? But I feel like that's just what it is at that point. Is that true? Okay, meanwhile, if I compute, if pi equals 2, okay, so there's a x that comes out of, like, you know, just the 1. And then there's an integral of 2 x plus 1. Oh my god, of course it got clipped. Alright. Okay, how do you integrate root x? What am I going to... See, I feel like I don't know how to do this in pi equals... Well, I can do it when pi equals 1. I don't know how to do it with pi equals 2, and I don't see how it's going to... Maybe I'm going down the wrong path then. Like, if I expand it, do I shoot myself in the foot because I expanded it? Right, like the pi is specifically not expandable. Like I'm not supposed to be able to like use an infinite binomial thing. So what kind of thing would... In general, if I have like some f of x to the pi and let's say pi plus 1 and I differentiate it. I feel like I'm so bad at this that I'm going to end up rederiving the chain rule or something. Then this equals like pi plus 1 times f of x to the pi times f prime of x. So that's fine. Does anyone know how to do U substitutions? Because I don't. Okay, here's something interesting, all right? When I differentiate root x plus 1 to the... wait, actually, that is really weird now that I think about it. If I take this thing and I differentiate it, do I get basically the same thing back? I get basically the same thing back, right? Because what happens is I get half of 1 over root x plus 1. And that's like something's up. So this is, yeah, like, yeah, conjugate is what I'm roughly thinking about. I'm trying to see. So left, right, and this is like 2 root x plus 1. Does that help me at all? Okay, you know what? Here's what we're gonna do. I'm gonna let u equals this thing. U will be root x plus 1 minus root x. All right. And oh, Lord, this is the kind of thing I'm really not good at. What we've learned is that du over dx is equal to minus half of u times like 1 over 2 root x plus 1. Which I guess is the thing that can happen. On the other hand, u squared is equal to 1 minus 2 root 2x plus 1. So this thing here is also equal to sorry, I have an extra 2. Minus half u times I'm gonna throw the half in actually. Oh, so I was supposed to do a trig sub, wasn't I? That's what's going on. Okay. Yeah, that is a trig sub thing. Dx is equal to... So we could do the u substitution and have the radicals go away now, I guess. If I didn't screw up already, which is a bold assumption. Yeah, but at least the radicals are gone, right? So it's like we're integrating u to the pi plus 1 over u squared minus 1. And yeah, this is gonna be a trig crap. Oh no. Okay, fine. Alright, so we're gonna... How does this work? Let u equals... Is it 10? I think it's 10, right? So, okay, this is equal to u 1 minus u squared. So we're gonna let u equals 10 theta. So... Oh no! Yeah, I might have messed up the constants already. I think I messed up constant. I dropped a minus sign, I think. But I don't know if this helps me. Like, hang on. Sign. Also, what's the? Oh my god. It's like it's a u to the pi. So okay, what are we going after? We're going after the integral now with du. So du is like, dx is equal to. Oh no. Oh the u goes the other way. Okay, never mind. We're alive. We're gonna make it. All right, things are fine. U to the pi is here. I thought the 1 minus u squared was on the bottom, and I was like, we're so screwed. But I think that's no. It goes the other way. All right. Did I fuck up the constants yet? Okay, so -2 root is okay. So u squared. Let's just write u squared minus 1. I changed my mind. We're not doing it this way. U squared minus 1 over u times u to the pi, and I can actually integrate that miraculously enough. All right, we're all good. Everything's fine. This better work. No, this has to work, right? Minus u to the pi minus 1 du. And then that is 1 over pi plus 1. Sorry, pi plus 2, u to the pi plus 2, minus 1 over pi, u to the pi, plus a constant, and then we put u back in. So u is equal to root x plus 1 minus root x. Okay, so it was actually just this. Oh. I thought the u squared minus 1 was going in the bottom, so I was just like, we're totally screwed the whole time. But it actually goes on the top, which is very different, because then the denominator is u, and we actually know what to do about that. Okay, did I get that right? I have like very low confidence in this answer, because I'm the kind of person that flips lots of signs. Bam, bam, bam. Oh my god. There's so many minus signs. U minus 2 root x. No, I think we're okay. This should be correct, right? Okay, I'm gonna... Is u squared, right? Wait, what? Did I screw up squaring? Wait, what? Isn't u squared... Oh, shit. It was a little too good to be true. Okay. Okay. Okay, that's a lot less good. I guess it basically comes down to like, can I solve for... I can solve for x in terms of u though, right? Because I know some reciprocal crap. So, okay, here's what we're gonna do. 1 over u is equal to this thing. Yeah? That's a reciprocal. So, consequently, u to the minus 2 minus u squared is equal to 4 root x plus 1. Yeah, okay, so you can actually solve for x in terms of u, but we're going to be a little more indirect because the thing we're actually going for is this, and that's a little easier to get. So now, instead of this garbage here, so d over dx was equal to this, and then what we're going to do is we're going to plug in the thing that we just got, which is 1 over, okay, 4 u minus 2 minus u squared. Okay, so this is all garbage. Oh, we're gonna throw this away. I'm gonna throw that away too. Okay, so alright, so now dx is equal to whatever I thought it was earlier. So dx is like something times du, and that something is u squared minus u to the minus 2 divided by u times 2? I hope? This is what calculators were meant for, so I'm like, oh god. Is that fine now? Okay, so then where was I? So u to the pi times u squared minus u to the minus 2 over u times 2. I think the 2 should be in the denominator? Seriously? Fuck. No, it gets flipped, right? Because this is 1 over? Maybe? Okay, you know what? There's a way to debug this, and it's called let's just fucking use Python. X equals 7. Or let's use x equals 6. U, it will be x plus 1 to the 0 minus. Okay, so... Okay, those are equal. And then minus u over... And then 2 times... Oh yeah. Okay, no, you're totally right. The 2 is... Yeah. Alright, fine. I see now. Yes, the u and the 2 should be on this. Okay, cool. Okay, so this is the integral of you pull out the 1/2, and then it's u to the 1 plus pi minus u to the pi minus 3. Right? Yeah, pi plus 1 and pi minus 3 du. which is this really beautiful expression called 1 over pi plus 2 u to the pi plus 2 minus u to the pi minus 2 over pi minus 2 du. And yeah, and then I have to put the definition of u back in. All right, very beautiful. Did I get it right this time? Is it that? Right, and then plus c, and there's no du here anymore. And it's off the screen, but hopefully that's it. Any other arithmetic mistakes? Oh my lord. There might be no factor of 1/2. How is there not a factor of what? Really? Did I drop it? No, this is a 4, right? So that 4 does. Hang on. Okay, never mind. Okay, cool. All right, we did it. Okay. How long did that take us? Oh my god. Yeah, okay. So at least we got it. As I was like, this is the kind of thing I'm really bad at. I'm not good at symbolic manipulation. And this is like about as artificial as symbolic manipulation is ever going to get, because you have root x plus 1 minus root x all to the pi. So I actually didn't think I was going to get it at all. But it turns out that u substitution actually works. So thank the lords for that. And let's add this in. Are there problem numbers for the integration bee that I can go off of? Oh, they are. Okay, beautiful. This is INT Bee 2020 semi 7. All right. So we don't need any of this crap. I don't need that. I don't need this. The problem statement. This. Note that. So we define so differentiating Yeah, it's funny. I actually remember a long time ago, I actually wrote for one of the integration bees, and I had no idea what I was doing because I like just don't do integrals, just broadly speaking. So a lot of my integrals ended up being like discrete sums in disguised as integrals. I don't know if I still have the problems that I suggested for that integration bee, but okay, cool. That's okay. I think this can be one line. I don't think this needs to be split in two lines. And this can be colon EQQ. And this can be merged as well. Okay, and then we put a box on this beautiful expression. Alright, we did it! Alright, cool. INT Bee. I don't know what to tag this. It's just like this problem exists. Uh